Hello guys, good day guys. You are welcome to our lectures. This is Nobel My Science Tutors Online, and for our class for today we are going to be looking at gravitational potential. Don't forget we started discussing gravitational fields. We've looked at, we have also discussed the relationship between universal gravitational constant and acceleration due to gravity. So we are still continuing our lecture on that same topic, but for today we're looking at the gravitational potential of a body that is moved from one particular point to a particular height. Is that okay? So that's what we're going to be discussing today, and then we'll also solve some problems in this particular lecture. So as I've always said, please get your writing materials ready, your notepad, your biros, your calculators, anything that you use to learn, please get them ready, and then so that we can go straight to the class for today. But before then, if you have not subscribed to this channel, please, what are you waiting for? Please subscribe to the channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, please help us to share this video and discuss with your friends and your colleagues that there is something that is happening in YouTube, and we are covering all the topics in the scheme of work for senior secondary school students in physics, especially for those who are preparing for JAM, for WAEC, and any external examinations. So this is Normal Science Tutor Online. Please reach us through the WhatsApp number that's showing on your screen, and then you are welcome to our lectures for today. So please, let's just go straight to the class. We are looking at, as I said, gravitational potential. Alright, so we have discussed before that the work done in raising a unit mass of an object from the ground level to a point H is equal to the potential energy of that body. And potential energy above the ground is equal to work done is given by mgh. Is given by mgh. Okay, so what this simply tells you is that at different heights, an object has different potential. Alright, so at ground zero level, the potential energy is zero. Then when you move the body to a higher level, the potential energy depends on that height. So, which means that at that height, we have a potential difference, right? There's a potential difference between the ground level and that height. Okay, so this potential energy is the potential or the gravitational potential energy of the body, and this energy is due to the gravitational field of the earth, and that's why we talk about the height of the body and acceleration due to gravity. So gravitational potential energy at a point is defined as the work done in taking a unit mass from infinity to that particular point, and the unit is joule per kg. Alright, the unit of gravitational potential energy is joule per kg. Alright, so we know that work done is equal to force times distance. Now in this case we are looking at distance, we are representing distance with arrow, and work done as F. Now when we discuss the Newton's law of universal gravitation, this is what we arrived at, that force is equals to G m1 m2 all over arrow squared. Now work done is equals to F times arrow. Okay, so we have that work done is equals to F times arrow. So in this instance, now put the F into this equation, and that's what I've done here. So if you put the F, which is this one, so we'll have that G m1 m2 all over arrow square multiplied by arrow. So this will cancel, then you have just one arrow there. So your overall equation is going to be G m1 m2 all over r. So this gives you the work done, and this work done we said is equals to what? The gravitational potential energy of the body. Now for a unit mass, the gravitational potential energy V is equals to minus G M all over R. Okay, so where M is equals to the mass of the Earth that is producing the gravitational field, R is the distance of the point from the center of the Earth, and G is the gravitational potential energy. So just take note of this equation because this is what you'll be working with. And then this is for a unit mass. Then this is for maybe when you have two masses that are acting on one another. Okay, so this negative sign indicates that the potential decreases as the object is moved from infinity towards the Earth. Okay, and the implication is that as the distance between the object increases, the potential energy does what? Decreases. So that is why you have this inverse of proportionality. As this one is increasing, this is decreasing. Okay, so, and as this one is decreasing, this will also be increasing. All right, so that is just what this negative sign indicates. And so this is all about gravitational potential, which is represented as V. So what I have discussed so far is that gravitational potential is equals to the product of the gravitational constant times mass all over the distance from the Earth, which is the radius. Is that okay? So having said this, we'll now go straight and solve some problems. This question says that what is the gravitational potential at a point on the surface of the Earth if G is equals to this and the radius and mass of the Earth are respectively 6.4 times 10 to the power minus 6 and 5.98 times 10 to the power 24 kg. So this is the mass of the Earth and this is the radius of the Earth that is given. Then this is G that is given to you. Now we have said that V is equals to G mass of Earth all over R. So what you need to do is just substitute these values into this particular equation that we have. Okay, so if you substitute into this equation, you are going to have that G is 6.67 times 10 raised to power minus 11, that's given to you, multiplied by mass of the Earth, which is 5.98 times 10 raised to power 24 all over 6.4, which is radius of the Earth, times 10 raised to power 6. Okay, so if you multiply this one out, you are going to have this as 39.89 times 10 raised to power 13 all over 6.4 times 10 raised to power 6. Okay, so by the time you work that out with your calculator, you have that the gravitational potential is equals to what? Use your calculator to point that out. You have 6.23 times 10 raised to power 7 joule per kg. Okay, so this is the gravitational potential for this particular question. This is a jam question and the question will not come differently. This is how they will always come. Alright, so there's not too much problem about this. Okay. So this is for your test. Please calculate the gravitational potential at a point of the Earth's surface. Radius of the Earth is this, mass of the Earth is this. So this one is just like the one we have done just now. This is just like what we just did now. So I don't think you have any problem in solving this. That's okay. So thank you so much for your time. This is just all about gravitational potential. Okay. It's just about gravitational potential. As we've said, it is work done in moving a unit mass from infinity to the Earth. Alright, so that is all about gravitational potential. So in our next topic, we are going to be discussing the solar system. That's what we'll discuss in our next topic. But for this is where we're ending this topic. But before I go, please, if you have not subscribed to our channel, what are you waiting for? Subscribe to the channel, click on the notification bell, so when we upload a new video like this, YouTube will notify you. Also invite your friends, share this video with them on your different social media platforms, and then give us a like, give us a thumbs up, and then click on the notification bell. Thanks so much. This is Normal Science Tools Online. You can reach us through the WhatsApp number that is showing on your screen. If you have any challenge, please just let us know. We are here to assist you and to make you better in physics. Thank you so much, and we appreciate you. See you in our next class.